Okay, in today's video I will introducing how to analyze Taguchi, which is optimization tools to get such graph, something like mean graph, and also signal to noise ratio graph that inform us which one we have to choose to get the optimum configuration for our optimum design. And also I'll give you a brief tutorial about how to get the ANOVA analysis, and also how we generate the general linear model, which is a linear equation that will give us a lot of information, and how to predict the results by only using a very concise equation that we get easily using Minitab. First of all, we have to have data analysis, data results, especially orthogonal array, Taguchi orthogonal array. This one is L9. L9 means there are 9 number of runnings, and in this case L9 that we use have has 3 levels, and also have 4 variables or design parameter. Alright, in this case this is my student works. He optimized how to get anti-ballistic hybrid material combining metals and also composites to get optimum design that can resist from rifle's bullet. So in this case he wants to optimize material thickness, layout, and also arrangement. We designed it by A, B, C, D, and also the level is only level 1, level 2, level 3 is variations. The material for metal, he's varying the material by aluminum 6 grade and aluminum 7 grade, and also titanium. And the thickness is varying in 16, 20, 24. And the layout, also the layout means the configuration, the right direction of composites. 0, 90 means 0 and 90, and also 0, 90 S, and the last one is 0, 90 minus 45 and 45, which is quasi isotropic. And also the arrangement, there are 3 arrangement, 2, 3, and 4. Yeah, just call it. And then he doing L9 orthogonal array simulation with 3 replication. It means we will separating between Taguchi analysis and also ANOVA analysis. The first step, we will doing the Taguchi analysis using Minitab. We open up the Minitab software and going to start main statistics and open DOE, design of experiment. There are a lot of things here, but we use Taguchi. Just create Taguchi design, and we know that our case is 3 level design, and number of factor means the variables 4, and we choose the design automatically generated by software L9 or L27. Of course we use L9, which is so simple, so few simulation if we compare with L27, which is so much and a lot of works to do, so we choose L9 and then just click OK. It will show off the orthogonal array that we've mentioned automatically. So we just put the results in here: result 1, result 2, and result 3. This is for Taguchi. For ANOVA, we will break it down. The result is all the way going down without any result 2 and result 3, because the repetition is will generate ANOVA easily to calculate in one row, not in 2 or 3 rows. It will make the computer confused. So in Taguchi, just put the results that we have done in the simulation or our experiment. So this column is obtained by simulation or by experiment. We cannot generate by something else. Maybe by equation it is possible, but most people doing experiment or simulation to generate this data. So just copy this and we paste in here. So now our data is set. We just doing the Taguchi statistic analysis using Taguchi DOA, Taguchi, and analyze Taguchi Design. That's very simple. And input all the results, all the response in here. Just select, just you drag it and select, and we choose yeah, just open it. Just open each tab to make you understand what is that, what's the meaning, what's the results. And we open analysis. We will display signal to noise ratio and also means. If you need to open up the standard deviation, just click it. I don't need, so just leave it be like this. And also the terms, I do not want to change anything. For option, yeah, we have to choose this. In this, the very important part here, signal to noise ratio, which one we choose. In this case, larger better, because specific energy absorption, larger the better for the parameter of performance for a material in absorbing energy. So we choose larger is better, and then just click OK. All is set and done. Just processed by the Minitab automatically, and we can import this, can export this to Microsoft Word. So this is the data that we got. We can just right click in here, send to Microsoft Word, for example, or PowerPoint, anything else you want. Just click Word, and then automatically will going to this, yeah, this one. This is the new one, worksheet number 1. Yeah, first of all, you have to clean all your Microsoft Word first, and you go to the menu tab and you send to Microsoft Word, and then it will automatically insert in your Microsoft Word. Alright, and now we want to analyze using ANOVA. ANOVA can very useful in order to get which one of the variables is contributing the most and which one is the less, and which is significance or not is analyzed by ANOVA. First of all, if you want to analyze by ANOVA, you just yeah, I recommend with new worksheet. Maybe just open new worksheet and we copy this as it is, nothing changes here. Just just copy this and we paste in this 1 2. Yeah, there are 27 simulation all, and the result is just cut this and paste in this, and also here click and paste in here. It means you're doing 27 simulation and the result is only one R1 here. Yeah, we can now analyze. This is A, B, C, D. Yeah, it's okay. A, B, C, D, anything you want to name it. Yeah, in here means the A factor A is 1, B is 1, C is 1, D is 1. It is and so on and so on. It means this is the variables or control factors, and this is the level. 1 2 3 is level or variation. And now we're going to analyze this using ANOVA. Just click statistic, ANOVA, and general linear model, and fit general linear model here, and we put the response in the response column. Just select and factor. You just drag A, B, C, D and select it, and then yeah, you can create with open all what is this, just leave it like this. Yeah, this is the same. The option is just yeah, confidence level 95. Sum of square for the test is adjusted type 3. And coding, the coding is for, you know, we want to generate a general linear model, which is linear regression, and we want to code every single level. So for level 1 means -1, level 2 is 0, and level 1 is +1. You have to input it in the equation, so you will get the exact results, the exact prediction of your SAE for this case, SEA, specific energy absorption. Just okay. Stepwise, what is this? Yeah, just leave it as default. Regular, the results. Just okay. I didn't change anything on the setup. Just leave it, and then this is the result here. The ANOVA here. This is show us the contribution. Significance. P below 0.05. Below 0.05 means significance. So in here the significance only on B, C, D, and variables A is not significant. And also the contribution of the biggest is D, and the second one is B, and then C and A. you can see in the adjusted sum square here, this is means the contribution. You can also see here, but yeah, because degree of freedom divide this sum square, so this is 68 divided by 2 is 34. This is also the same, 1116. So this is the ANOVA, and amazingly we will get automatically, this is the regression equation that will predict your results. In here we have A1, A2, A3 means variables A with level 1, 2, 3. We have 3 levels for each variables. And if A1, for example, A1 appears on your for example in this first row, you know that A1, B1, C1 and D1. There is no A2, there is no A3, there is no B2, there is no B3. In here also there is no C2, C3, and there is no D2, D3. It means you just input the A1 with number 1, and A2 is 0, A3 is 0. It means 0.68 plus only B1 who appears in this column, in this row. It means B1 is equal to 1, so 12.31 times 1 minus 2.91 times 0, because B2 is nothing here, and also B3 is 0, and so on C1 and so on D1. So you will adding up and the result is almost the same with this. Okay, you can try by your hand using Excel, and then yeah, that is the prediction. For example, if you not found in here all the variable is 3, you can just input it, put here, yeah, and with this equation we will get your prediction of SE as AE as EA as a specific energy absorption. Okay, that's all, and you can import to export to Microsoft Word, I mean, and you will get automatically in here all set. Yeah, this is just a coefficient for each variable and level. How to get the optimum one from this regression? You just find out which is the coefficient give you the largest. Yeah, the larger. In here, this is yeah, this is the largest, A3, and for B is B1. B1 is the largest. For C, we can get this is C. C3 is the give the largest point, the largest result coefficient, and also D2. We can see also on the in here signal to noise ratio. For larger better, yeah, it will give you we can choose larger better means we can choose A1, A2, A3 is actually not significant. You can choose any of this material, and then for the B you can choose B1. In this regression, B1 gives the largest coefficient, and also for the C is C3. C3 in This equation also gives the largest coefficient, and the last one is d2. Let me check. Yeah, d2 is the biggest, the largest means, and also the largest signal to noise ratio. That's how we use Minitab to apply Taguchi analysis and also ANOVA. Thank you. That's all for today.